5-Minute Mystery by the DSVK family. In episode 5, we investigated the vowels, which stop right before the seventh one. Naturally, this leaves us with 6 vowels: A, E, I, O, U, and Y. In episode 6, we investigated the clock, which also stops right before the seventh 6, naturally leaving us with 0, 6, 15, 24, 33, 42, and 51. The seventh 6, just like the seventh vowel, is just beyond the pattern. There is a pattern to how 7 is represented, or more accurately stated, not represented. If 7 is not represented, then what is it? An excellent question. Changing our perspective will help us find our way to 7. Remember inverse reflections? Now seems like a good time to investigate them further. 1 can be -9, 2 can be -8, 3 can be -7, 4 can be -6, 5, weirdly, is also -5. Wait, is that really an inverse reflection? Yeah, the center of a reflection does that. Neat trick, huh? 6 can be -4, 7 can be -3, 8 can be -2, and 9 can be -1. Now we have a bunch of negative numbers. Negatives always remind me of debt. Are you sure this is the right way to go? Well, maybe we can shift the negative perspective into something else. Something less like money and more like trees. Trees? Yeah, this can be the earth and this can be air. But where are the trees? Good question. I forgot some fire and some water too. I see your trees, but some of them look pretty strange. Like number 9 could blow over, and number 1 probably fears the weed whacker. What about number 7? Something very peculiar is happening over there. Is it? Yeah, look at these timelines. By plotting trees 1 through 9, we can compare them. Next, we need the inverse reflection or root number for each tree count. Finally, we center all tree counts on middle 0. Can you see it now? 7 just happens to be the only number whose count balances perfectly between its inverse reflection and its reflection inverse. -3, -2, -1, 0, 1, 2, 3. That makes 7 counts. Wait. I do remember some math. And 3 minus a -3 is actually 6 and not 7. So I don't know how you made it 7, but you mathed it wrong. You are quick. Math is for the future. Counts are for the present. So right now we are on -3. We give it a count because the present counts. When we move to -2, -2 becomes our second count. This move between two counts is like a line between 2 points. The line is 1 in math, one step into the future. I don't know about this. Seems like you're stretching things a bit. See this baking pan of brownies? I love brownies. Right now we have 1 pan. No math, nothing in the future, just 1 pan of brownies, 1 point. I want a brownie. Okay, I'll make 1 cut. 1 cut is movement into the future and thus math. 1 cut makes 2 brownies, 2 points. We went from 1 to 2 and math tells us that the answer is 1 more than what we originally had. 1 more to share with you because the current count is 2. Enjoying that brownie? Check out these seeds. These are all in the present, therefore these are all the first point. Time passes and we see the seeds have grown. The triangle has 3 arms, making a total of 4 counts. The square has 4 arms, making a total of 5 counts. The pentagon has 5 arms, making a total of 6 counts. And the hexagon has 6 arms, making a total of 7 counts. Wow! So can I have the last brownie? Sure, but can you explain 7 and its inverse reflection pattern? Hell yeah! 7 has an inverse reflection of -3. That means when I dig a hole 3 feet deep and drop the acorn in, those 3 feet are connected by 4 points. When the acorn grows 3 feet taller, it'll reach the last 3 points. That's 7 points for 6 feet. So, can I have the brownie now? Whoa. Definitely brownie whoa.